Hey guys, hello everyone, and welcome to the class. I have started this session a little late because there was some problem with there were some technical problems. Um, all right, today in this particular session, we are going to talk about some very important concepts from general organic chemistry. I'll be talking about like few of the basic ways of finding out the acidity order and the basicity order. ठीक है, तो ये वाला part we'll cover in this particular video, and we'll try to finish this up as I'm like, because you know these types of questions are generally asked in CSIR-NET exam. Okay, so acidity order of acidity and basicity. Okay, basicity in in the organic molecule. So that's what we are going to cover in this class. Just a second. All right, fine. So this is the topic which we are going to cover, and let's start with it. So the acidic nature of a particular organic compound depends upon few points. Okay, I have written those, so I'll be just giving you from there. So there are two things in which we understand the acidity of a particular molecule. Okay, so the first thing is that either that particular element, like either they lose hydrogen atom, right? They lose hydrogen ion and form a negatively charged conjugate base, okay, and forms negative charge conjugate base. That's the first thing. And the second thing which can happen is either they accept a pair of electron, okay, so or they accept a pair of electron, and that's how also they will be forming a conjugate base in this case. So for example, let's say you have this kind of a species that AH is there. So this is the first type of like acidic molecule in which A is going to form a negative. This is the conjugate base of the conjugate acid, and the H plus ion will be liberated in this case. The second case is that, let's say I have BX3 and I am giving some, let's say I have NH3. So what is going to happen, that this BX3 is going to accept the lone pair of electrons of nitrogen, and making this species a like this will be formed like this. So BX3 minus, and along with that you will be having NH3 plus. Okay, so these are the two ways in which a particular molecule, a particular organic molecule, is said to be aromatic. Good afternoon, Gayatri. Hi. So that is one of the thing which we have to discuss. Like that's one thing which you should know. Okay, so compounds which on losing H plus ion forms a stable conjugate base, they are said to be strong acid. Okay, so you have to remember this particular point, that on losing, okay, on losing H plus ion, if conjugate base which is formed, okay, conjugate base which is formed is stable, okay, formed is stable, what we say in that case, that means that the acid is strong. Okay, acid is strong. Or you can just find out the relative like order of acidity of acids based upon this particular concept. So we are going to apply this, and we are going to see some questions based upon that. Let me first of all give you some like a kind of flow chart which will help you to identify. Okay, so acidic nature of the compound is proportional to, acidic nature is proportional to stability of conjugate base. First thing is that means the negatively charged species. Okay, so negatively charged species, that's what we called it as conjugate base, and it's proportional to the strength of electron withdrawing group. So if you have electron withdrawing group, what it will do, it will stabilize the negatively charged ion, right? So that's why the presence of electron withdrawing group increases the acidic nature. It's inversely proportional to the strength of electron donating group. All right, that means, and it's also proportional to some of the like some of the effects, you know, those effects like minus R effect, minus I effect, minus H effect. This is resonance, this is inductive effect, and this is hyperconjugation. and it's inversely proportional to plus R effect, plus I effect, and plus H effect. You know, you have to give more preference to the resonance effect, then you have to give more preference to the hyperconjugation effect, and the least preference will be given to the inductive effect. Okay. Okay, now one more thing which you should know is that the acidic nature can also tell you about the different other properties like Ka values, pKa values. So let's write down that. So acidic nature, okay, acidic nature is basically proportional to Ka. So if Ka is higher, that means acidic nature is also high. It is also inversely proportional to pKa value. It's proportional to the concentration of H plus ion. It is proportional to the, inversely proportional to the pH. Alright, it's also inversely proportional to pKb, it's directly proportional to it's inversely proportional to Kb, directly proportional to pKb, it's directly proportional to 1 upon OH minus ion, or you can say it's directly proportional to POH. So these all things you should know, okay, that how you are relating your acidic properties with all these given standard like ways of understanding it. Okay, Ka tells you about the dissociation constant for the acid. pKa is like you do the negative of log of Ka, right? That's how you get pKa. So I guess that's what you know. Okay, now let's talk about carboxylic acids, because we know that carboxylic acids are the most stable, are the most acidic functional groups. Okay, so carboxylic acids. Okay, carboxylic acid. So let's take some of the carboxylic acid. Let's say I have R, C double bond O, OH. This is one of my carboxylic acid. Now, if I find out its conjugate base, so how it is going to be? The conjugate base will look like this. Okay, that's how it will look like, and the stability of this particular conjugate base is going to decide all the other factors. For example, if I take one of them and if I give you HCOOH, then if I give you CH3 COOH, then if I give you CH3 CH2 COOH, okay, and I have to arrange them according to the order of the acidity. So you know ki okay, if you find out the conjugate base over here, so this is what the conjugate base will be. In this case it will be like CH3 C double bond O minus, here it will be CH3 CH2 C double bond O minus. Okay, now you know these groups are electron donating groups or electron releasing groups. Okay, electron donating groups. We have already seen that electron donating groups decreases. If you have more better electron donating group, it decreases the acidity. So if I have to write down the acidity order, okay, acidity order, so how I am going to write down the most acidic one? So these electron donating groups are going to decrease my acidity. Okay, the most acidic one is that is HCOOH is most acidic, then comes your CH3 COOH, because the strength of electron donation is more for ethyl group as compared to the methyl group, right? And the least acidic one is this, that is propanoic acid. So that is how we do. Okay, that's how we do for the acidic strength. एक और क्वेश्चन ले लेते हैं. Let's take one more easy one and let's see the relative acidic strength of the groups here. So let's take one more example. Okay, in this case I am going to change the position of an electron withdrawing group. Okay, let's say I have CH2 COOH and I have chlorine here, then I have CH2 COOH, and if I ask you that which of them is a better acid, whether A or B, who is a better acid? Okay, तो करना क्या है मुझे? I have to see, first of all I have to look for what kind of conjugate base I am having, or you can just understand it on the removal of this H plus ion, this will be the conjugate base will be formed in both the cases, right? This is going to be your conjugate base. Now this conjugate base is going to be stabilized because of the minus I effect of chloride group, right? Inductive effect is there. Now you know that the inductive effect follows the DNP rule, right? Yeah, very good, Ranit. So the inductive effect follows DNP rule, that is distance, number and power. So first of all you go for the distance. So since the distance of these groups, since the distance is near for this, so there will be more inductive effect, more minus I effect in B, which will stabilize the B, and that's why acidity order of B is more than A. Okay, so that's how we approach this kind of question. Okay, एक और example लेते हैं. You guys have to tell me. Okay, example in which I have CH triple bond C and COOH. This is one of them. Then I have CH2 double bond CH COOH, and the other one is CH3 CH2 and COOH. Okay, fine. So which of them is going to be the highly acidic? Okay, you have to tell कि which of these is the highest acidic. So यहाँ पर क्या चीज़ देखना है कि with respect to this, like the conjugate base will be formed here, CH triple bond C COO minus. Now you have to look for the percentage S character on the carbon attached just to this. Okay, so you know that the minus I effect decreases if the percentage S character decreases. Okay, and the electronegativity also decreases with respect to the percentage S character. Now you know this is sp hybridized, here it is sp2 hybridized, this is sp3 hybridized. The percentage S character is 50% in this case, it's 33.3%, and it's 25% in this case. Now you know that if it is so, then which is more electronegative? So you should write down these points. Okay, I'm just going to write down here that your minus I effect decreases, okay, if percentage S character decreases. Okay, so minus I effect is directly proportional to your percentage S character. All right, yeah. So the one which has more S character will have more minus I effect, and that's why it is going to stabilize the carbon ion, and that's how you will be having a better or a more stable or a better acid in this case. Okay, so option number A is highly acidic, then comes this, and then comes this. Okay, so this is the least acidic one. Okay, so fine, this is what it is. Understood? कोई डाउट है, किसी को कुछ पूछना है? Anybody want to ask anything? एक और एग्जांपल लेते हैं. Let's take this in this way. Okay, let's take like cyclic ones. Okay, so you guys have to tell me which will be more acidic, A, B and C. ठीक है? Tell me, which will be more acidic, A, B and C? C. Okay, Ranit is saying C. Anybody else? You have to understand this thing, कि as the size of ring increases, what happens to the electronegativity of the ring? If the size of the ring increases, what happens to the electronegativity of the ring? So the electronegativity of ring also decrease. As the size of the ring increases, your electronegativity of the ring decreases. ठीक है? So electronegativity of the ring decreases, so that's why if the electronegativity decreases, minus I effect also decreases, and in that particular case the conjugate base will be less stable. So acidity also decreases. So the most acidic one is this, then B and then C. ठीक है? C is the least acidic one among them. ठीक है? That's how you have to approach this. All right, ठीक है? Substituted aromatic acid, ठीक है? I'll take those also. We'll go for that also. ठीक है? चलो ले लेते हैं, उसी को देखते हैं. ठीक है? Let's take that. Substituted aromatic molecules लेते हैं. So Fine, let's say we have COOH, then we have NMe3, okay, with a plus charge on this. The other one is this, we have COOH and we have bromine here, okay. Then I have let's say COOH, let's say I have CH3, and at the end I am taking only benzoic acid. Okay, you have to arrange in the order of acidity. Okay, so what is going to be the acidity of these? Arrange karo. Which one will be more acidic? This is first, second, third and fourth. First, second, third and fourth. First, second, third and fourth. कौन सा सबसे ज़्यादा एसिडिक होगा? First, second, third and fourth. Look at the molecules. B. Okay. Okay, I got B in 1-2 cases. Okay. Just tell me one thing. Nitrogen having a positive charge on it. Nitrogen having a positive charge on it. What effect does it apply? It will try to attract electron towards itself with more, like with the more nature, like the electronegativity of, you can understand in this way that it is very unstable to have a positive charge on the nitrogen group. So in that case what it will do, it will try to attract electron towards itself with what effect? With minus R effect. Okay, it's going to apply this minus R effect with a more ability compared to bromine. Bromine, although it's electronegative, but because there is a positive charge on the nitrogen, that is going to trigger this particular thing, that is going to make this particular molecule more having more minus R effect, and because of that this particular one will be highly acidic. Okay, so acidity order I am writing, तो एसिडिटी ऑर्डर 1 का सबसे ज़्यादा होगा. देन अब तुम देख सकते हो इलेक्ट्रोनेगेटिविटी ऑफ सेकेंड इज लाइक यू विल बी हैविंग सेकेंड वन. इसके बाद दिस इज गोइंग टू गिव यू दिस प्लस आई इफेक्ट, राइट, एंड प्लस आई इफेक्ट डिक्रीजेज एसिडिटी. यहाँ पर कोई भी इफेक्ट नहीं है. सो फोर्थ वन विल बी देन कम्स योर फोर्थ and the least stable will be third one. So this is going to be the correct order of acidity. ठीक है, समझ में आया? So this will be the correct order of acidity. So किसी एक ने सही बताया था, रनित, very good रनित. ठीक है, so that's how it will be done. रीज़न क्या है? रीज़न I just told you, minus R effect in this case. यहाँ पर minus R और minus I दोनों है. Although you know that you give more preference to the resonance effect, but here the strength of the resonance effect is more as compared to this. Reason is the positive charge on the electronegative atom. ठीक है, that is making it more like prone for that. Okay, चलो एक और क्वेश्चन करते हैं. Let's take one more question. इसी को थोड़ा सा और कॉम्प्लेक्स करने की कोशिश कर रहा हूँ मैं. ठीक है, just look upon this. I have COOH, I have NMe3 plus. Okay, then I am going to bring the other groups. ठीक है, then I have AsMe3 plus. ठीक है, this is arsenic. Then you have COOH and you have PMe3 plus phosphorus. ठीक है, and the last one is this. Okay, you have to tell the order of your acidity. ठीक है, order of acidity. ये 1 है, ये 2 है, ये 3 है और ये 4 है. order of acidity बताना, जल्दी से ट्राई करो. How to tell the more acidic proton in any compound? Okay, in any compound you have to look for a particular hydrogen. If it is removed, the negative ion which is formed, whether it is stable or not. ठीक है, I'll give you some examples. उसके भी example करेंगे. ठीक है, okay. Devulu is saying option A. Anybody else? just try it. Okay, you have to arrange them, you have to arrange them in the order of acidity के order में arrange करना है. Okay, you have to arrange in the order of acidity. So what you have to apply, which concept you have to apply? Okay, just tell me one thing, that whether this, if I bring this particular thing COO minus, and if I look for this particular benzene ring, if I am just looking for benzene ring, so where my charges will be developed on this benzene ring, on what positions with respect to this COOH, I will have electron rich centers on the benzene ring. Can anybody tell me? On which positions will I have more like charges or electron rich centers on the benzene ring? Can anybody tell me? Okay, fine, let's do it. So basically in this case what happens, that the resonance itself stays on the carbon, like the carboxy group itself, okay, and on the benzene ring it is the only the inductive effect. Okay, it has more of the inductive effect than of the resonance effect, okay. So inductive effect is applied more over here. So if you look for this in the options given over here, so which option or which effect is going to like counter this particular thing is the resonance effect of that. Okay, so if you look on these molecules, you have nitrogen. Just a second, just a second. All right, so yeah, sorry about that, there was some disturbance from background. Fine, so we have these molecules, we have to arrange them in the order of acidity. So you remember there was one effect which I told you, that effect was called as your inductive effect, follows this rule, DNP rule. It goes like distance, number and power. So first thing is to look for the distance. So all these groups are going to apply these inductive effect, because on the negative charge, on the electronegative on the electronegative group or electronegative atom, you have positive charge. So being near to this, since the distance for this and this is near to this carboxylic acid, they are going to apply more inductive effect compared to this, okay, because of that distance value. So now once the distance is same, you have to look for number. So number is also same, both of them are 1 1. Now you have to look for the power. So the one which is more electronegative, phosphorus being more electronegative, is going to apply more inductive effect, more minus I effect, and that will stabilize this COOH, and that will make this 3 more acidic. Okay, acidity order I am writing. So 3 will be more acidic, then comes your 2, and then comes your 1, and the least acidic one will be 4. So this will be the order of your acidity for the given molecule. Okay, that's how we do for it. Alright, now somebody was asking regarding ki how to identify for a given molecule. Okay, okay, fine, I got it. Fine, so yeah, Ranit is correct, that will be on meta. So if you are going with that resonance effect also, on the meta position, if that is electron rich, that will be taken away from by these particular groups, and that will stabilize that negative charge on the meta position, है ना? And that will make that particular conjugate base more stable as compared to the first one. So that is also one of the explanation which you can go through. Okay, so if you are given with a certain molecule, let's say I have been given with this, and I have to identify ki which is the acidic hydrogen over here. Okay, which is the acidic hydrogen. So I have hydrogen at position A, position B, position C, and position D. I have hydrogens at these 4 positions. I have to tell that which of these hydrogens are acidic ones. Okay, that's the question. So how to approach that particular thing? The basic way how to go with that is just to find out, first of all, you draw the carbon ion at all these places. Okay, so let me draw it. So if I draw a carbon ion at A, this is what I will get. If I draw a carbon ion at B, this is what I will get. Okay, acidic hydrogen means you are removing H plus ion. So once you remove the H plus ion, you will get a carbon ion. So that's what it is. If you remove it from C, you will get it here, okay, and if you remove it from D, so you will be getting carbon ion here. Now you have to look for which is the most stable carbon ion, okay. Now when you go for A, it is resonance stabilized. Option B is also resonance stabilized. Option C is not resonance stabilized. Option D is also not resonance stabilized. So like A, B, C and D, that's what we have. So C and D you can cancel out. These are not resonance stabilized. A and B are. Okay. Now in A and B, which is more stable? So both of them are resonance stabilized, both of them have 1 resonance structure, but A being the A being a 1 degree carbon ion is more stable, because here the inductive effect is also least, okay, the plus I effect from the alkyl part is least over here. So what's the reason? You know that the order of stability of carbon ion goes like this, that is 1 degree, then 2 degree, then 3 degree, it goes like that, okay. So 1 degree carbon ion is more stable because of less plus I effect, ठीक है. हाँ, terminal keto methyl group, yes, good Ranit. So option number A is the correct option for this particular question. Likewise, yeah, likewise we can go for it. Okay, so for any molecule you can identify the more stable and the less stable ones. Let's do one more, ठीक है, एक और करते हैं. Now I am giving you this molecule, okay. You have to tell that which proton is more acidic. A, B and C. I got 3 protons. Which one is more acidic? चलो इसको एक थोड़ा सा और extend कर देते हैं. Let's make it D also. ठीक है, let's make it D as well. So I have up till here. So C and D. Which one will be more stable? Good afternoon, Praveen. Which position is going to give you the more acidic proton? That's what is the question. Okay, so which position will give more acidic proton? The answer is B. Okay, again same thing you have to do. C or D, to C, okay, you can check it out. So if I draw for A, I get a carbon ion at this position. If I draw for B, okay, I get a carbon ion at this position. If I draw it for C, I get a carbon ion at this position. Okay, and if I draw it for D, so I get a carbon ion at this position. So that's how I will be having. Now you know that in the first option it is resonance stabilized. In the second option, it is resonance stabilized from both the sides. So being having two groups which are making it resonance stabilized, yeah, this is called active methylene group, right? So this position is the highest, or this is the highly acidic position. Active methylene group is the name which we give it to them. C is also stabilized by the resonance but destabilized by the inductive effect, and option D to is not stabilized one. So B जो है that is relatively most acidic proton here. Yeah, very nice. Yeah, the order will go in this way only, that B will be highly acidic, B position, then comes A, then comes C, and the least one is D. Okay, this is the order of acidic protons in it. ठीक है. So that's how we approach order of acidity. Okay, next जो भी session लेंगे हम लोग उसमें, because today's session was disturbed by the technical problem and all, so I cannot extend the class. I am hungry, I have to go for my lunch also. ठीक है. So next session जो भी लेंगे उसमें we will discuss the basicity and the basic order. ठीक है, वो भी discuss करेंगे, just to know कि how to identify basicity of a given organic molecule. ठीक है. I guess this much was helpful to you guys. Try to solve questions related to that. Okay. And before ending the class, let me tell you that there are classes running on Unacademy Plus. Okay, so if you are interested in joining Unacademy Plus, so you can join, and my referral code for Unacademy Plus and all the details are given in the description of this video. The referral code is NHudaLive. Okay, so you can use this referral code to get 10% discount on the subscription fees. Okay, yeah. Thank you so much for joining, guys. Take care. and have a great day. Bye bye.